and D and will be muted throughout the meeting.
Okay, good afternoon, everybody. It's Morgan Bailey from Rocket Lab here. We'll start the call in just a couple of minutes. I think we're waiting for a few more folks to join. But thank you very much for taking the time to join us today and talk about the TROPICS mission. Okay, it looks like we have most folks, so we might make a start. Welcome, everyone. Thank you so much for joining us today to talk to the team from NASA and Rocket Lab and our mission partners working toward our very first launch for TROPICS. During today's call, I will introduce some of the folks on the call. They'll provide a little bit of information about their role in the launches and the mission, and then we'll move into some Q&A as well. So for now, let me introduce the folks on the call. We're joined by Dr. Will McCarty, who's the program scientist from NASA Earth Science Division. We also have Ben Kim, who's the program executive for NASA Earth Science Division. We have Dr. William Blackwell, the TROPICS principal investigator from MIT. We have Bradley Smith, the Director of Launch Services for NASA's Space Operations Mission Directorate. And of course, we have Peter Beck, the founder and CEO of Rocket Lab. So to kick off today's call, I might pass to Dr. Will McCarty first to share some information about his role in the mission and perhaps what he's looking forward to ahead of first launch.
Hi, I'm Will McCarty, again, program scientist in the Earth Science Division at NASA headquarters. Effectively, what I do at NASA headquarters is I'm a program scientist in the Earth Science Division. And what that means is I work within the weather and atmospheric dynamics focus area. So all the weather satellites that we launch within Earth Science, I basically serve as the interface between headquarters and the satellite projects themselves. My background is I am a meteorologist. So this is one of those things that really excites me. I've worked with many weather satellites over the years. And so my role here with TROPICS is really to enable the team and as well as, relay the good results up to headquarters. This is something that very much ties to my research background before I came to headquarters. So it's very exciting to me, and I'll just stop with that for right now.
Thank you so much, Will. Ben Kim, would be great to hear from you.
Oh, thanks very much, Morgan. As Morgan said, my name is Ben Kim. I'm the program executive for the TROPICS mission. But I'd like to talk about NASA's Earth Science Division. So we use the vantage point of space to understand and explore our home planet, improve life, and safeguard our collective future. So to create this great science, we utilize a balanced mission portfolio that ranges from the really large observatories like Landsat 9 at around 6,000 pounds, down to the very smallest of satellites like TROPICS at around 12 pounds. This mix within our portfolio allows us to maximize the science per taxpayer dollar and thus do more science than if we only focus on the large missions. So during the 2020 Atlantic hurricane season, we had so many tropical storms and hurricanes that we ran out of names in the predefined list, and we had to swap to the Greek alphabet. The same thing happened in 2021. In 2022, we only had 3 hurricanes that hit the United States, but that included Hurricane Ian, which caused more than $100 billion in damages and more than 100 fatalities. The threat to our friends and neighbors is real and repeats every year. TROPICS aims to improve our scientific understanding by obtaining microwave observations that allow us to see the inner structure of these storms approximately hourly. These observations will complement the existing weather satellites and ultimately can be tied to the broader understanding of the entire Earth system. In the longer term, we hope to gain a better comprehension of the basic processes and environments that affect tropical cyclone structure, size, and intensity. And then this knowledge will help aid weather modeling, which will allow meteorologists to advance forecasts, enable better warnings, as well as improve disaster management. In the shorter term, many operational organizations like the National Hurricane Center and the Joint Typhoon Warning Center and many others are ready to receive our tropics imagery to help inform their forecasters. So I hope all of you are as excited as I am about the benefits tropics will bring to us, and will cheer alongside the team as we head toward the launch. Thank you.
Thank you so much for that overview, Ben. Next, it would be good to hear from Dr. William Blackwell, please.
Thanks, Morgan. I'm Bill Blackwell. I work at MIT Lincoln Laboratory, and I'm the principal investigator of the TROPICS mission. So I lead the mission, and very much looking forward to this new type of observatory using a constellation of very tiny CubeSats. These are about the size of a loaf of bread, 10 pounds, to make measurements of tropical cyclones from space. And we'll be getting data that we've never had before, which is this ability to look in the microwave wavelength region in the storms with hourly cadence, to look at the storm as it forms, intensifies. And we hope to improve our understanding of the basic processes that drive the storms and ultimately improve our ability to forecast track and intensity.
Fantastic. Thanks so much, Bill. Bradley Smith, it'd be great to hear from you, please.
Yeah, thanks, Morgan. So I'm the Director of Launch Services at NASA headquarters. You've heard from the payload science side of the house, right, with Ben Kim and with Drs. McCarty and Blackwell. I'm actually on the launch vehicle side of things, so these payloads will entrust themselves to myself and Pete on launch day to get them where they need to go successfully and safely. And it's hard to believe that we awarded this launch service back in late November, early December timeframe, and here we are just 5 months later, and all the mission integration work that had to go into that, and all the analytical development that has to go into matching a payload and a launch vehicle. And here we are just 5 months later, and we're on the precipice of getting ready to go fly. So I'm incredibly excited about this mission. I know it's near and dear to a lot of Kiwis' hearts, you know, given what's happened recently with Cyclone Gabrielle. So it seems apropos that we're getting ready to go fly from Mejia. And Pete, looking forward to really smooth launches coming up here in May.
Fantastic. Thanks so much, Bradley. We are absolutely looking forward to it. And you're quite right, it's a very special mission for us. So last but not least, Peter Beck.
Well, there's a hard act to follow. Thanks, Morgan. Naturally, we're super excited to get these launches away. There's 2 launches in pretty quick succession. And this launch is a little bit unique in the fact that we always use the kick stage to trim the orbits, and occasionally we use it to do inclination changes. But in this particular mission, we use it to trim the orbit, but we also do push it to the side and give it a very special inclination so that it can the spacecraft can be optimized for its data collection. So yep, we're looking forward to getting this one away. Ironically, we've been moved by a couple of days due to weather, but we're still looking at a fairly on target launch and getting that away safely.
Great, thanks so much, Peter. Okay, so we will open the floor to questions next. If you can find the raise your hand button down there at the bottom of your screen, I'll push the button to allow you to talk. If you could please just introduce yourself, and if you know who you'd like to direct your question to, please do so. Otherwise, I'll invite the panelists to answer as they see fit. Okay, it looks like first we have a question up from Jeff Faust, Space News.
Hi, this is Jeff Faust of Space News. Question probably for Peter and or Bradley Smith. If you can describe in any more detail the decision to move these 2 launches from Virginia to New Zealand, what drove that decision, And what sort of additional costs does that incur by having presumably to ship the satellites and move personnel to New Zealand? Thanks.
Yep. Pete, you want to start out and I can jump in from a NASA perspective?
Yeah, sure. So, the timeline in which we could get the spacecraft launched out of Virginia didn't correlate with the timeline that was required to get these spacecraft in orbit to, for the storm season. So one of the advantages of operating multiple launch sites is you can kind of pick and choose, and we're able to wedge a slot into New Zealand and get them down there and get them away. And from a cost perspective, it's there was no additional cost, that we can move missions between the two pads pretty seamlessly.
Yeah, and Jeff, just tagging onto that from a NASA perspective, we're largely launch site agnostic. As long as the launch provider can actually meet the mission requirements, it's their choice where they want to go. So if you remember back a few years ago, we actually flew a Mars mission from Vandenberg, right? That was a manifest congestion sort of thing, but we're really launch site agnostic as long as the launch provider can meet all the mission requirements.
Okay, great. Thank you, Bradley. Thank you, Peter. Any other questions, folks? Please push the raise your hand button and I will unmute you. Alternatively, if you'd like to pop questions in the chat, please feel free to do that. In the meantime, while we wait for folks to raise their hand, I might ask some of the questions that we've received via Instagram and Twitter for Ask NASA. Question here, best for the science team. Will TROPICS measure temperature and humidity in all spheres?
Here, I can start off with that. So TROPICS will measure basically in the troposphere primarily. It'll have a little sensitivity to the stratosphere as well. But what it's really targeting is, the water vapor is primarily in the troposphere, in the world part where we live in. There's a little bit in the stratosphere, but it's a much smaller amount. So what it does is that with the microwave measurements, though, it really lets us not just get the temperature and moisture in the clear sky environment, but it also allows us to see the temperature and moisture structures, as well as the cloud and precipitation structures within the storms themselves. So it's that inside and outside of the cloud, all sky perspective that TROPICS really brings to the table. And in addition to that, it's the time information we get. That's the new part of this, the constellation approach, where we're going to get revisits on the order of once an hour. And that allows us then to not just see the temperature and moisture structures, but the time evolution of those structures. And that's really important to us because at NASA and throughout our entire Earth science portfolio, we kind of investigated of a system of systems. We look at how the atmosphere, how the ocean, how the land, how the high atmosphere, the lower atmosphere, how all these things interact, and not just temperature and moisture, but all the chemistry and constituents that can exist in the atmosphere as well. And so what the big point here is TROPICS is really going to give us a better understanding of the evolution of tropical systems and by, its low inclination, by flying over the tropics repeatedly and allowing us to see this revisit. But that also, on a larger umbrella of Earth sciences, allows us to tie things like hurricane intensity, hurricane evolution to the larger Earth system and the impacts it can have. A hurricane can upwell the water underneath it, which can affect the sea surface temperatures and the ocean circulations on small scales. It can, have huge impacts in terms of the larger scales of the flow around the globe because there's just so much energy within these storms. So, the exciting thing about this is that, it's the ability to see inside the storms, but it's also the ability to see how the storms are changing over short periods of time. Bill, did you have anything else you wanted to add?
Yeah, I was just going to point out how valuable these microwave measurements are, and we've been making them for 40 years from space. But the thing that has eluded us is this ability to capture the dynamics of the storm that you mentioned. So this new hourly cadence that we'll get with the constellation is really going to push us forward in terms of what the observations will be able to do to explain how things are changing in the storm.
Great, thank you both. Another question coming from online. Will this make weather forecasting more accurate and precise?
I can take this one.
Yep.
Yeah, I was going to say, actually, it's, in all honesty, this is what my background was as a researcher, was getting satellite data into numerical weather models. And the reality of it is that we were already very dependent on particularly microwave data in our forecast skill and how our weather models perform. And why that is because these data allow us to essentially provide the instantaneous initial conditions. Basically, what is the temperature and moisture state of the atmosphere that you can then put into the model, and then the model runs and basically can create forecasts of the future. What we don't have well right now that will really get out of tropics is exactly what Bill said on the last question. It's that dynamics information. It's the evolution, because what that gets in a weather prediction sense is it's not just the temperature moisture data that's inherent to the observations. By having that time information, by having a constellation upsampling the storm on a median rate of every hour, when you put that into the model actually has to evolve and develop the entire wind structure behind it. So you get this dynamic information about how the winds in the atmosphere are changing to match the evolution of the temperature and moisture observations that we're seeing and we're putting into the model. So it's really providing this extra dimension using the time dimension to really understand not just the thermodynamic state, the temperature and moisture profiles and the cloud profiles, but how the entire atmosphere, the winds and the temperature and everything is interacting together to evolve to capture the evolution that we're able to see from the constellation of satellites.
Great, thank you for that comprehensive answer. Another question from Twitter, fun question, asks, would it ever be possible to do something like the movie Twister, where you place a bunch of sensors inside a storm to learn more about how it's formed, or has that always just been a Hollywood idea? Perhaps Will or Bill, that's best for you, I would say.
Yeah, I could probably answer that one as well. So at NASA, one of the reasons we do it from space is a satellite gives you the ability to orbit around the globe and see a large portion of the entire Earth system. But other things we do at NASA actually involves going into and measuring the storms directly. So, for example, we have numerous airplanes that we fly either into the storms with a number of probes attached that can look at the microphysical characteristics. And that's a big word for basically what the little ice and cloud particles look like inside the storm at really the droplet by droplet basis. And then we have larger planes that can fly above the storm and use remote sensing satellite-like observations, but you're doing it from just basically tens of miles versus hundreds of miles in space. And so we see details from aircraft that we can't see from space, but we use those to feed each other. So we use the aircraft observations that we really are measuring inside the storm to better understand our space observations. And then we can then apply our space observations and what we learn, we can apply that in a global sense to really understand the entire Earth system.
Fantastic. Thank you for that answer. We have a question from Clive Simpson on the call. So Clive, please go ahead and ask your question.
Thank you very much. I just wanted to ask about the constellation. You've got 4 satellites in this constellation. Did I understand correctly that you originally were going to have 6? And does that make any difference to the information that you can gather, or were the other 2 just a spare?
Yeah, so it does make a difference. So with 6 satellites, we would get a slightly better revisit rate. So falling back to 4, we lose about 10 to 15 minutes of revisit, but we're still better than our requirement of 60-minute median with only 4 satellites.
Thank you.
Just to add on to that, we also had a engineering qualification model that we upscaled and we're calling the TROPICS Pathfinder. So this was a single CubeSat that we successfully launched back in June of 2021 to use as a proof of concept of the entire mission, to prove out the system from the satellite all the way through the ground system, through the algorithms and the data processing. So there actually is one additional TROPICS CubeSat that's currently on orbit, except it's in a polar orbit instead of the low inclination.
Okay, thank you. Could I ask one other quick supplementary question about the launch time and day? You mentioned at the beginning that there were some weather delays. Is that subsequent to what we already knew, or was that previous?
Peter, that's probably a good question for you.
You know, we're originally planning to try and get it away on the 1st, but it looks like it'll be the 3rd as a storm front comes through. So just a couple of days.
Okay. Thank you.
And we'll continue to monitor that weather system through the weekend and provide a new no earlier than date in the next day or so. Hopefully that weather clears quickly so we can get these on orbit. Okay, we've got a question from Kenneth Chang from the New York Times. Kenneth, please go ahead.
Great, thank you. I was just wondering, do you need to have both launches work to get all 4 remaining satellites up, or if something goes wrong, is TROPICS basically not successful? Thank you.
Possibly Will or Bill, that's a good one for you to jump in on the science, I believe.
Yeah, I guess the simple answer is we wouldn't hit that 1 hourly revisit rate. But the reality of it is you know, if we get one of the two and we still have 2 satellites, there's still a lot to learn from these data. It's still going to provide, by having the 2 in the same plane, potentially good revisit, you know, of the storm, just, you know, and quick cadence because of the 2 orbits, but not necessarily that hourly repeat, because you're going to you don't get the second orbital plane covered. But in reality, I think there's still plenty to learn. We know that from Pathfinder, really all of our other requirements we're really doing well with. It's really just that temporal cadence that we would lose by only having 2 of the 4 satellites. Bill, is there anything else you wanted to add?
Yeah, it's certainly going to be interesting to have a single plane of 2 satellites overflying a storm. You'll get the rapid succession of measurements for those 2 in the same plane. So that's going to be very interesting for, you know, convective activity and things that are changing very rapidly. So we'll get those occasionally, even in one plane.
Okay, great. Thank you both. Sophie Sanchez, looks like you've got a question, so please go ahead. Sophie, did you have a question you wanted to ask there? Okay, we can come back to you.
I'm sorry, I was muted.
That's okay, go ahead.
Yeah, Sophie Sanchez from Cosmic Chicago. I had a question, I guess, for Bradley Smith and then perhaps Peter Beck. Given the change in launch sites from Virginia to New Zealand, I was wondering, Bradley, if you could speak a little more to the changes in operations and things that went into like switching launch facilities, and then Peter Beck too, if you can just speak to you know, what had to be done on your end, any advantages the company has in having 2 different facilities and 2 different locations. Thank you.
Yeah, hi Sophie. So a little bit of the contract deliverables, you know, some analytical products like the actual trajectory, you know, launching from Wallops versus launching from New Zealand. Some of that work had to be redone and revalidated, but really from an operational standpoint, you know, I'll let Ben talk about, you know, logistics of shipping to New Zealand versus shipping to Wallops. But really, the launch site change was essentially, outside of those few things, was largely not something that bothered us at all from an NASA perspective.
Yeah, and from, you know, from our perspective as well, the work was relatively trivial. You know, obviously, as Bradley said, we had to change some trajectories, but the most important thing here is to make sure that these spacecraft are successfully launched and up in time for the storm season, and this gave us the most clearest path to ensure that. So that was the most important thing, and we'll do whatever we need to do to make sure that we can deliver those spacecraft for the storm season, and that in this case meant getting them down to New Zealand and taking opportunity of an open spot.
And then from the logistics perspective, there was a little bit of work to do in order to make sure that we did all the transport safely and export control and all that kind of stuff. But it was pretty minor. That being said, I think our ESSP mission manager down in New Zealand is probably having the worst time of it because I keep calling and messaging him in the middle of the night, forgetting about the time difference.
Thanks so much for that question, Kenneth. Okay, I think we've got a question from Lauren Leifer. Would you like to go ahead and ask a question?
Hi, yeah, thank you so much. Hi, I'm Lauren from Gizmodo. I'm just wondering, will having this additional data from TROPICS help to mitigate the damage and human toll from some of these storms? Are there plans in place to translate this additional forecasting knowledge into, say, more or better alerts or more information to the public about hurricanes as they happen?
Yeah, so one thing that's really exciting about this mission is that fundamentally we haven't really operated in a NASA bubble. We do work quite closely with both partners within our own government domestically and international partners in terms of how to utilize this data. Just 2 weeks ago, we had a meeting looking at how to utilize this data and in terms of really application. So how do you make the data help inform decisions and really where the rubber hits the road? And as part of that, we had representatives from both the Joint Typhoon Warning Center and the National Hurricane Center at that meeting. And so we do collaborate with NOAA and with partners in defense in terms of how to utilize this data, both so what it can provide a forecaster sitting at a forecast desk is really that situational awareness, that real-time, instantaneous. If you can get the data, the quicker you get the data to them, the quicker they can look at it and interpret it into their larger forecasting activities. But what we also focus on then is how we get the data to the weather models, because at the same time, every forecaster around the globe more or less starts their forecasts with looking at models as a key piece of their forecasting guidance. And so if you can get this data into the models, it'll then hopefully improve the performance of those forecasts as well, which then translates to the forecaster, which then translates to, everybody who looks at a phone forecast, a weather forecast on their phone. And really the ultimate goal there, though, is that this data will hopefully help fill in these data gaps by having this time revisit that we continue to talk about. And what that really does, though, is it basically, again, it fills in the knowledge gap on the forecaster side as well. So the idea here is that, ultimately when it comes to forecasting a hurricane is you want to be accurate in its position of landfall, and you want to be accurate in its intensity of landfall. And having this extra data really will fill out, fill in the data voids in terms of how those forecasts both, forecasts from a forecaster sitting at a forecaster desk or forecasts in the weather models, which of course feeds back to the forecaster. This will all help fill in those gaps to really, potentially improve, the impacts of really hurricane landfall, which is where, it affects most people.
Thank you for that answer, Will. A quick question here from online, from Instagram. What is the total cost of TROPICS? Ben, maybe a question for you.
So this TROPICS is within our Earth Venture portion of the portfolio, and so the cost cap to this mission is $30 million. So that covers development and operations and all that sort of stuff.
Okay, great. Thank you for that answer. Another question from online. Can we help stop hurricanes from coming if it's predicted before time?
I wish I could remember the actual numbers, but the amount of energy that is inside a hurricane is borderline unfathomable. Basically the water and the heat and the processes that generate all the heat that drives a hurricane. It's a big heat engine. That's literally how it works. As water is released from the heat through condensation, which drives the storm. The storm then drives its own circulations. So it's kind of it's an engine. It's a repeatable cycle as long as nothing comes in and disrupts it. So to alter, the strength of a storm or the direction of a storm is a daunting task and really takes an insane amount of energy that you would need to disrupt the amount of energy that's contained within the storm in a large sense. But what it does do, of course, comes back to the forecasting, the concept of forecasting, which is if you can't redirect it, what you can do is do your absolute best to improve your forecasting of it, improve your understanding of the processes. And then that translates to not just the forecasting events, but the forecasters deal with emergency managers and local governments and state governments. And so it really is this whole tie of basically from science to action where, it's not just understanding and doing the science, it's actually using this data and trying to figure out how to make this data inform decisions downstream, which while you may not be able to prevent property damage because you can't move things out of the way, at least you can save human life and really provide situational awareness and as much warning time as possible to basically all of the customers of this data.
Thank you, Will. I might open the floor for this question because I imagine people have got different responses, but another question from online. What's one thing people should know about tropics?
I can start on that one. So to me, I think one of the really interesting features of Tropics is the team behind it. You've heard about on the launch side, it was very agile to turn around these new launches. The science team was working hard with a lot of partners internationally and domestically on using the data. The engineering behind Tropics is astounding. The fact that we were able to miniaturize these instruments into something so small and affordable and launch them and do new science with that is astounding. So just the people behind all these innovations and game-changing technologies is astounding to me.
Yeah, and this is Will McCarty. I'll follow up with that because it basically ties into what Bill just said, which is the team. But the idea here is that this is it's a shift in thought in the sense that we have built very large satellites before, and trust me, we still need the large satellites. They still provide the highest fidelity data that we could get, and what this does, it's the CubeSat revolution. It's all these small distributed satellites. What we get from this though is the ability to add more information to the flagship satellites that we already have. So it's the idea that we can take operational satellites, big giant research satellites from NASA, and then basically add more information through these CubeSats. And to me, it's really exciting to think about, how we can build 4 of them or 6 of them or 7 of them, if you include Pathfinder, and then put them up in a way that, that we're really going to see the evolution, because it's really hard to see things change in time through observations. We've always used models to help serve as that time interpolator. And there are a lot of really smart people coming up with really creative ways on how to use this data, even more so than we thought when we first proposed the mission or funded the mission. People are always going to come up with new ideas, and they're going to see new things, and basically the scientists underneath it, and as well as the engineers, are really, I can't wait to see what happens once they do get their hand on, a full constellation of real data, because they'll probably do even more creative things than we can think of right now.
So following up with Bill and Will, I'd like to focus everybody's attention on the innovation. So if one of the channels on the TROPICS mission is 205 gigahertz, which is a novel channel for us, which gives us more information than we previously had. So in complementing the larger weather satellites, we're also getting some new innovation as well in these tiny, compact sizes. So again, these CubeSats are about the size of a loaf of bread. So I would really like to stress the innovation on this mission.
Thank you, Ben. Anyone else like to add to that one thing that everyone should know about the TROPICS mission? So feel free to add if anyone else would like to comment.
Yeah, Morgan, I would just echo what Bill and Will said on small satellite front, that has a launch component too. For 25 years, LSP and NASA has known how to get big monolithic payloads that weigh, tens, hundreds and thousands of metric tons on a dedicated launch, right? But for a shoestring budget like $30 million, I know $30 million sounds like a lot of money, but in our business, it's not. How do I enable science to get on orbit for a cost that's commensurate with that $30 million budget, right? And that's the problem that we've been relatively successful in solving here with the TROPICS mission, getting them a ride that's both affordable and responsive to what they need. And, my team, working hand in glove with Pete's team, have been able to do that. And that's a success story for TROPICS, I think, from my perspective.
I would echo everybody's thoughts here. I mean, we're just so incredibly honoured and that with that comes a tremendous responsibility for the science. We have one job here, and it's a really important one that we've got to get right. So we're looking forward to getting these spacecraft away and giving that science team the data and the science they need to really make an impact.
Okay, fantastic. Well, I'll open the floor one final time for any last questions. So please do raise your hand or pop a question in the chat. While you're thinking through those final questions, just a reminder for everyone to follow Rocket Lab and NASA social media channels, and you'll find the latest and greatest about the launch timing and mission updates there as well. And of course, you'll be in contact with myself and the NASA team in the coming days just to stay up to date on how the mission is progressing. Looks like we've got a final question from Sophie Sanchez. Please go ahead.
Hi, thank you for taking another question. I had a question that you guys kind of touched on right now regarding kind of the cost of the CubeSats and the new tech that's involved. When I just think back to like past hurricane-related satellite missions like Cygnus, which I think was around 300 million compared to 30 million, I was wondering if there was any tech that kind of grew out of the past hurricane missions that you can touch on, or was the tech that's being used for this or developed for this mission entirely new or answering entirely different problems or forecasting issues? Just because like I know when I've spoken to past principal investigators, they always mention running out of space or Omni satellites or money to add new tech. So I'm just wondering if there's anything that this the TROPICS mission is built on, or if it's entirely new tech that you guys have added. Thank you.
Yeah, I'll have a couple of thoughts on that. So the instruments, the payloads are different, but there are commonalities with the spacecraft bus. So we have learned some lessons with Cygnus with respect to some of the parts that they use, things like reaction wheels, how they operate the spacecraft, their concept of operations, and how they do the ground processing on a constellation of in their case 8 satellites. So we certainly have learned a little bit in terms of how to operate and execute the mission, and some of the parts from the spacecraft as well.
Okay, great. Thank you, Bill. Any final questions from those on the call? Okay, well, fantastic. Thanks for joining, everyone. I will give our panelists a chance for any final remarks. If there's anything we didn't cover today that you think we would like to share, quick around the room. Bradley, anything you'd like to share with folks on the call?
No, just go TROPICS.
Thank you so much. Go TROPICS indeed. Will, anything you'd like to add?
NASA has a really long history of studying precipitation and tropical cyclones from space. We've had the TRIM mission, which launched in, I believe, '97, and the GPM mission, which launched earlier last decade. And so when you put that all together, it's about a 25-year data record, and of course a lot of history prior to that in terms of developing and getting the missions going. It's really exciting to me to see how this continues to evolve and how TROPICS plays a role in this larger umbrella of studying and understanding tropical weather and precipitation from space, and really getting the ability to get this vision all around the globe, which is hard because you don't have weather radars everywhere, on the ground. And so it's really going to give us a nice, complete story, and we're going to get this added information bit of not just what things look like at a specific time or how they look over long data records where you aggregate the things together. We're really going to get that time information to see how things are evolving really on an hourly rate. And that's really exciting to me.
Fantastic. Thank you, Will. It's exciting indeed. Ben, anything that you would like to add?
I just want to remind folks that space is really a team sport, and I really want to thank all the partners, both internally like LSP and ESSP, as well as, of course, MIT Lincoln Lab, Rocket Lab, Blue Canyon, KSAT, and all the others that really participated and made the TROPICS mission possible. Thank you all.
Thank you, Ben. Bill, anything to add from you?
Just to echo the excitement of everyone, here we are on the cusp of these launches, and we can't wait to get these satellites up there and taking this new data.
Absolutely. And Peter, anything you'd like to add?
Look, we got one job to do, and we've got to do it a couple of times in a period of days. So we're squarely focused on that, and go TROPICS.
Absolutely. Okay, well, thank you so much for joining, everybody. A recording of this call, of course, will be made available. Contact me if you'd like a copy of it. Thank you for joining the call. Thank you today for all of our panelists. And with that, go TROPICS. Thanks so much.